All right, so there are no notes to take with this, but there is one last thing that I want to show you about solving systems of equations, and that's using graphing and using Desmos. So I've got two problems. Well, actually, it's the same problem, but it's up here twice. If you've got a piece of paper handy, go ahead and copy these problems down. And it says to first solve it using substitution, and then solve the same problem using elimination. We would have done this as like a warm-up problem in class. See if you can remember, okay, how do I solve this using substitution? How do I solve this using elimination? We'll go over the answers, and then I want to show you something that we would consider using the graphs of these. So go ahead and pause the video, copy the problems down, solve this one using substitution, solve this one using elimination. All right, so I hope that you paused the video and were able to work these out. If you'll remember, for the first problem, in order to solve an equation using substitution, the first thing we want to do is get one of them to have a variable that's isolated, right? So the easiest way that I found to do that was to add y to each side first in order to get the top equation as x is equal to. So that would cancel, and we would find that the top equation is actually x is equal to 11 plus y, which we could then take and substitute in for our x value here, right? And so if you did that, and I'll just go ahead and uncover the answer here. If you substituted in, there's our work. If you substituted in the y plus 11 plus y into the second equation, you would have then had to distribute the two, and you get 22 plus 2y plus y is equal to 19. This is just solving that second equation after making that substitution. You would have had to combine like terms, which 2y plus y is 3y. And then subtract 22 from each side. 19 minus 22 is negative 3. And so when that all was solved after dividing by 3, you got y is equal to negative 1. Then you would have taken that and, of course, substituted in back into, I substituted back into the original equation into here. And so I plugged in negative 1 where I saw the y in this first equation. And I got x minus negative 1, which changes to plus, is equal to 11. And then when you subtract 1, you get x is equal to 10. So the answer that we got here was 10, negative 1 by solving using substitution. So don't forget about substitution. Using the elimination method over here, it was pretty straightforward as to how you were going to eliminate, because we already had, the x's of course did not have the same coefficient, but we notice here that the y's both do have a 1 in front. So we would be able to eliminate those by taking the second equation. And how could I make negative 1 and positive 1 0? Well, I would add those together. Negative 1 plus 1 would be 0, so that would be eliminated. And so if you eliminated the y's, you end up adding the x's, which is 1, there's of course there's a 1 right there. So x plus 2x is 3x is equal to, and then with the numbers, once this eliminated, 11 plus 19 gives you 30. If you divide by 3, you notice that x is 10, which is exactly what we got over here. By then substituting back into the original equation, so the x minus y is the one that I used. So I took that 10 and I substituted, if I can get my drawing tool back up here. Yeah, I took the 10 and I substituted back into this equation. 10 minus y is equal to 11, subtract 10 from each side. And then there is a negative 1 right here, so we did have to divide by negative 1. And so we get y is equal to negative 1. So even using elimination, if you remember how the elimination method worked that we worked on throughout the beginning of this week, then you've got 10 and negative 1. Still comes out to be the answer. So it does not matter when you're solving just a system of equations in general, whether you choose to use substitution or elimination. It really depends on which method works better or which method you're more comfortable with. But that is just sort of a review of what we have done so far as solving a system of equation. Now, the last thing that we have to go over is how do I solve a system of equation using graphing. Let's see if I can I want my draw and zoom to go away. There we go. All right, so how do we use graphing to solve a systems of equation? Well, if you take these two equations and you type them into Desmos. So think about the ones. If you don't have Desmos open, you might want to go ahead and open it up. So we've got x minus y is equal to 11, and 2x plus y is equal to 19. Take a second and just type that into your Desmos. If you need to pause the video, you can while you get it typed. All right, so hopefully you've got those equations typed into Desmos now. And so here's what your screen should look like. You typed in both of the equations into Desmos, got the value, and if you click right here, where at the point at which those two lines intersect each other, what do you notice about that point? It's 10, negative 1. And that is the answer that we got in both cases with substitution and with elimination over here. And so, hate me if you want to, but although the substitution and elimination methods are necessary for us to know, and we need to know how they work and how they get us to arrive at the right answer, you can solve a system of equation by simply graphing it in Desmos and finding the intersection point. So let's try another one of these. And again, you should have your Desmos up, out, and open. And so for this set of equations, you can ignore that line. That's just where my cursor was when I typed these in. But go ahead, if you have your Desmos open, go ahead and type in, if you had the system of equation, y is equal to 2x minus 5, and then y is equal to 2x plus 1. Go ahead and type that in. You might think to yourself as you're typing this in, well, I see that the coefficients of the x are the same, and so I could use elimination. And you could use elimination. However, when you type them into Desmos and you find that they create two lines, remember the answer is going to be the intersection point. And so for this particular set, what happens if they don't intersect? Because in our last example, we got the answer by finding the intersection point, right? Well, if they do not intersect, of course, that means there is no solution. So two parallel lines which never intersect are going to result in a no solution. So if you are solving a system of equations and you find the intersection point, that is your answer, 10, negative 1. If they do not cross, that is no solution. And then we're going to try one more like this. Go ahead and type these in, and you'll probably notice as you're typing them in what is true about them. Well, they are exactly the same line. And so if you end up graphing them, then of course they look like this. So if you end up with the same line, well, where do these two lines intersect? They intersect everywhere, right? They're actually on top of each other. And actually, if you were to click on the red, or in your case, it might be a different color, but if you were to click right here, it would actually take that line away and it would show you the blue one. They just lie right on top of each other. And they actually intersect at every single point, right? They have infinite intersection points. So if they end up being the same line, this is going to be infinite solutions. So there's going to be 3 different types of graphs, and we're going to try some on our own here in just a second. But this is just a really short video, and of course there's nothing to write down here. This is just showing you what's going to happen on the by using Desmos. So let's try this one on your own. So take a second, see if you can figure out either what is the solution, where do they cross? If so, you get your x and y value. Are they parallel, in which case there's no solution, or are they exactly the same line, in which case they're infinite solution. So take a second, go to Desmos, type that in, see what you get. If you need to pause the video, go ahead and pause it. All right, so I hope you got those typed into Desmos and you were able to find a solution. When you type these in, your graph should look something like this in Desmos. And you find that your answer is where they cross. And so the answer you should have got is negative 1, negative 1. So x is negative 1, y is negative 1. And that is your final answer. So no use in substituting. You don't have to eliminate. You just type them both in and get the intersection point. All right, let's try this one. So take a second. If you need to pause the video, go type this into Desmos. All right, I hope you took the time to pause the video and go type this into Desmos. If you did, you should have got a graph that looks similar to this. And so your answer, your final answer would be that x is 2 and y is -1. That is the point at which these two lines intersect with each other. So again, no use in, you don't have to substitute, you don't have to eliminate, you just find the point at which they cross. 2, -1 is your answer. All right, try this one. All right, I hope you took time to pause the video and type this into Desmos. And if you did, then you should have got something that looks similar to this graph. And this graph, the point at which they intersect, of course, we see that there is no intersection point. If you scrolled on and on forever, you would find that these never intersect. And so this would have been a no solution to this particular problem. They never intersect, so there is not a solution. And then the last one that we're going to do, go ahead and type this into Desmos and see what you conclude. All right, and so the last example here, you should have got, oh, I deleted my graph, but it's infinite solutions because these two lines, of course, are the same, and they end up lying directly on top of each other. They're not parallel, so don't put no solution when you only see one line. If you only see one line, they are the same line, and they cross infinite amount of times. So your practice over the next couple of days is just going to be to use Desmos, type in all of your systems of equations, and analyze the graphs to decide whether you have an example of a solution, which is where they cross, no solution when they don't cross, or infinite solutions, which is when they are the same line and they cross infinite amount of times. Make sure you email me if you have questions about solving systems of equations with graphing.